Hey guys, Mr. Backenberg here. In this video, we're going to look at two famous triangles. Evaluating trig functions of specific angles used to require trig tables or a slide rule, but now most people generally just rely on a calculator to help them out. But there are a couple of specific type of right triangles that we're going to focus on because their side ratios can be found geometrically, and typically every student in trigonometry should be able to find these special ratios without needing to use a calculator. And we're going to focus on a 45-45-90 triangle and also a 30-60-90 triangle. So back in geometry, we learned a special side length relationship in a 45-45-90 triangle. And what we learned about was that a 45-45-90 triangle is an isosceles right triangle. So along with these two angles being congruent to each other, we were also going to have two sides that were congruent to each other. And I'm going to label those sides with x's right now, because the side length doesn't actually matter when we're building these ratios. Now, along with these x's on the legs of this right triangle, the hypotenuse ends up being whatever that x value is times the square root of 2. Now remember, these x's in here just stand for some general length. And we don't know exactly what that x value is, but as we're setting up these ratios, again, it doesn't matter what the x value is. So if I wanted to look at this 45-degree angle down in the bottom left-hand corner, if I wanted to set up that sine of 45 degrees, then what I would do is I would take the opposite side, which is x, over the hypotenuse, which is x root 2. Now this fraction can be simplified down because we've got that x showing up on top and on bottom. Those would cancel each other out, so then we would just get 1 over the square root of 2. But we don't like to leave radicals on the bottom of fractions, so we should rationalize this to being the square root of 2 over 2. So the sine of every 45-degree angle is the square root of 2 over 2. Similarly, if we wanted to set up the cosine of a 45-degree angle, cosine is the adjacent side, which is x in this case, over the hypotenuse of x root 2. So we're seeing similar things happening to what we just saw with the sine, so this should also simplify down to the square root of 2 over 2. And then if I wanted to find the tangent of a 45-degree angle, tangent is opposite over adjacent. So what we're doing is we're making a fraction out of both of these x sides, and if we take a number and divide it by itself, the answer we're always going to get is going to be 1. So even though we don't know exactly what this x value is, we're still able to find the sine, cosine, and tangent. Now we can also find those reciprocal trig functions as well. So if we wanted to find the cosecant of the 45-degree angle, what we would do is we would take the hypotenuse and put it over the opposite side. So these x's would cancel out, so we would just get the square root of 2 over 1, which just ends up being the square root of 2. For the secant of a 45-degree angle, again, similar things are going to happen in here. We would take the hypotenuse over the adjacent side. Those x's would cancel each other out, and we would just get the square root of 2. And for the cotangent of a 45-degree angle, cotangent is adjacent over opposite. And again, x divided by x is just going to end up being 1. So like I said, we're able to find all of these trig functions in this 45-45-90 triangle without even knowing how long those sides are. Now, just like we've got a side length relationship in our 45-45-90 triangle, we also have a side length relationship in a 30-60-90 triangle. And in our 30-60-90 triangle, we based everything off of the short side, and the short side is across from the 30-degree angle. So I'm going to call that my x. If we know this x, then the hypotenuse is 2 times that x value, and the longer leg across from the 60-degree angle is x times the square root of 3. So now what we're going to do on this one is we're going to focus on this 30-degree angle up here right now, and we're going to do all of our trig functions based on that 30-degree angle. So if I want to do the sine of 30 degrees, sine is the opposite side over the hypotenuse. Now we've got this x and 2x in here, and just like we saw with our 45-45-90 triangle, this x value doesn't actually matter because what's going to happen in here, because these x values would be the same, we're allowed to do a little canceling with those. So those x's would cancel out, we'd have a 1 left over on top, and we'd have our 2 left over on bottom. So the sine of a 30-degree angle is 1/2. Now if I wanted to do the cosine of 30 degrees, cosine is the adjacent side, so that'd be x root 3 over the hypotenuse of 2x. And again, we can cancel out those x's on top and on bottom, so we would get root 3 over 2. And for our tangent of 30 degrees, tangent is opposite over adjacent. Now when we cancel these x's, we end up getting 1 over the square root of 3, but we should rationalize this since we don't like to leave radicals on the bottom of our fraction, so we should get root 3 over 3. Now we can also look at doing those reciprocal trig functions as well. So if we do the cosecant of our 30 degree angle, cosecant is hypotenuse over opposite. So when we cancel out those x's, we just get 2 as our cosecant value. For the secant of 30 degrees, secant is hypotenuse over adjacent. Now we can cancel out those x's to get 2 over root 3, but we should rationalize our fraction, so we get 2 root 3 over 3. And then we've got our cotangent of this 30 degree angle, and cotangent is adjacent over opposite, and we cancel these x's out to get just root 3. Now here we're looking at that exact same 30, 60, 90 triangle, but we're going to look at it from a different perspective using the 60 degree angle this time. If we take a look at the sine of our 60 degree angle, sine is opposite over hypotenuse. We can cancel out those x's, so we get root 3 over 2. If we look at the cosine of our 60 degree angle, cosine is adjacent over hypotenuse. When we cancel out those x's, we should get 1/2. And when we look at the tangent of our 60 degree angle, tangent is opposite over adjacent. We can cancel those x's, so we get the square root of 3. And if we look at doing our reciprocal trig functions as well, so if we look at our cosecant of this 60 degree angle, cosecant is the hypotenuse over the opposite side. Cancel out those x's and we get 2 over the square root of 3, but we rationalize that to get 2 root 3 over 3. The secant of our 60 degree angle is the hypotenuse over the adjacent side. Those x's cancel out, so we just get 2. And if we do the cotangent of our 60 degree angle, cotangent is the adjacent side over the opposite side. Cancel those x's to get 1 over the square root of 3, but then rationalize that to get root 3 over 3. That's going to be it for this video. Thanks for watching.